Hello guys, how's it going? I hope that you are doing well, and I hope that in today's contest was also good for you. Let me check if I see myself. I can see myself.
The average.
Okay, so how was everything? Did you guys participate in the contest first, in the binary search contest that we prepared, or not? Today, as you know, we're gonna talk salam. Alright. As you know, today we're gonna talk about binary search. Hello, Shahrukh, and hello, Shahnur. Hi, salam. Yeah. Today we had the contest. Let me bring the contest. As you can see, no one has accepted all the problems, but yeah, I hope that it was good. You tried the first question, it was good. Okay, good, nice. Salam. Hello. So, as you know, and last time, if you were in the stream yesterday, the tablet was not working. Today I brought a lot of things, a lot of work, and you can check from here all of them. If there was any issue, I can try them one by one. So just to make sure. But this one that I'm trying right now is working well, so probably we don't need that. I am not getting interested in coding. Maybe it's better if you don't give up so quickly and continue. Maybe it's because you have just started. And yeah, we will discuss all of them. Good, nice. How many the rest of you have solved? We will wait for maybe 1 or 2 additional minutes, and then when others join as well, we will start discussing binary search. 5. Good, nice. Well, about that, I've said about it. I said my opinion about this in the videos of newbie. That's what you should do to get out of newbie. I don't know if you have watched it so far or not, but I think I really recommend to you to watch that first. Can you say me when you use return in divide and conquer methods? This is not the topic that we're going to discuss today, but if you want, we can discuss about divide and conquer as well. Very simple. So, I didn't participate, but I want to learn more about the solid chains that we do in binary search, right? Good. Did you make your own mashup content channel? Yes, I did. You can join the Codeforces Group from this link if you want to participate. As you know, these topic streams first, we have the contest that you can think about the problems yourself, and then we are going to solve them in our class. Our topic stream is not in class, it's a topic stream. So, okay, so without any more further ado, let's start talking about binary search. Let's start. Nice, thank you, Gaurav. That means a lot. We just started, but now I'm gonna start. Okay, so let me prepare this, and then we can start talking. Well, as I said, today we're gonna talk about binary search. Let's first see what binary search is. And I know that maybe many of you know it already, but we're gonna start from the beginning, and we're gonna solve the most challenging problems at the end as well. The last problem that we solved is difficulty is more than 2000. So we're gonna start from the basics, and at the end we're gonna solve a hard problem and challenging problem, and it is really a beautiful problem as well. We're gonna solve that too. So what binary search is? Well, there is a game that I'm sure that many of you have seen this game before, and I saw that most of them see it in TV shows, etc. And people play in that, but they're not really good at it, and they play badly, and they go on your nerve. That's why they play like this. For example, they have to guess a number, like guess the height of a mountain, and they just they have to guess it, and they do it very poorly. Well, the point is that assume that you want to guess a number, and for example, guess a number like x, and you know that x is in the range from 1 to n. For example, at the beginning, assume that the range of x is from 1 to 100. And each time you can guess some number. I mean, there's an unknown number. Each time you can guess some number, assume that this unknown number is x. Each time you can guess some number, and it's like y, and it tells you if this number is greater than or equal to this. I mean, if you should go up, or it's greater than this, or it is lower than this, smaller than this, or it is equal, and you have guessed correctly. I mean, you probably have seen this game before in TV shows, etc. And people really do not do well in it. For example, first they guess 10, and then 20, 30, and then 35. And then the point is that why they play like this. But they can play a lot better. So the question that binary search answers is that what is the best way to solve this problem? What is the best way to guess these numbers so that you can answer this problem very fast? I mean, you can find the final number with the fewest possible number of questions. What is that? What is the minimum? Yeah, the question is that what to start with. What do you think is the best to start with and guess at the beginning? Exactly. Please give me a reply. I didn't see what message you said. Yeah, we talk about these things as well. So, no, binary search is not hard. We will see. I mean, we go into step by step. Exactly. Well, the best thing is to start from 50. Why? Because n is between 1 and 100. So, the first question that we can ask is that, I mean, we can start from the middle elements. For example, in here, because it's from 1 to 100, the middle ones are 50 and 51. They are both in the middle. But anyway, the best question that we can ask is to ask 50, the middle one. Why? Because if we ask 50, if it is more than that, the next time our range will be here. If it is less than that, in the next time our range will be here. And if it is equal, we win instantly. And the point is that in the worst case scenario, we will have fewer number of elements to consider. So the point is that in the worst case scenario, next time our range, the number of possibilities, next time is going to be 50. But if we ask 70 or 80 at the beginning, as soon as we ask 80, the point is that if it is greater than that, it is going to be very good because there are only 20 numbers greater than that, and our game would be easier. It would be easier to guess. But on the other hand, it's going to be so probable when you choose 80. Because there are so many numbers before 80, it's so probable that it is less than 80. And then what you want to do? Then your situation will be very hard because you're going to have to handle with 80 numbers. So the point is that the wisest choice is to choose the middle one. And this is what, I don't know why, but people do not do. And it's fair. Have you seen this? Have you had this experience seeing this game? And you're like, why you don't guess the middle one? Have you also had the same experience? I mean, this happens a lot. I see it a lot of times. That people, play very poorly in this game. Yes, but we have to find out. Yeah, if we might be lucky, and even in our first guess we're right. But we want to see that we want to provide an algorithm, provide a way that in all the cases we can solve the problem very fast. So that's the point. We have to. Yeah, and we assume that they are random. Maybe we have additional data as well. For example, these numbers are more probable than these ones. But we can even ignore that, and without even considering that, and even considering that we don't have any additional data, and it can be any of these numbers, we can choose the middle one. Yeah. So we can include ternary search in another video in the next subgroup. This one is about binary search. But if you want, next we can talk about ternary search as well. So anyway, as I said, the first question is the best. For the first question is the best to ask 50. And assume that we asked 50 and we understood that the number is less than 50. We should go down. Then what do you think should be the next number? What do you think the next number should be that we ask? So we understood that it is less than 50. So what should we ask next? Exactly. Again, we have numbers from 1 to 50. The middle ones are 24 and 25. And we can just ask, we can ask 25 next time, because our range is from 1 to 49, and we can again ask the middle one. And the point is that again it divides it into two parts. I mean, again, and both of them are almost equal. It's like we are splitting the set of possibilities into two equal parts. So I mean, if this is our range, we ask the middle one, and by doing this we're gonna split it into two parts, which have almost equal size, and they are half of the size of the previous range. And by doing this, we are sure that in the next time, definitely our range will be divided by 2. And this is going to be so good for us. I mean, because if we have a number and each time we are dividing it by 2, our range is being divided by 2 each time, the number of questions that we need to ask is so few. Because it's so few questions, we can reach a range of size 1, and then we are sure that that is the answer. That is the answer. So the point is that we can always ask the middle one. And if we ask the middle one, assume that our range, let's talk about a more general case. Assume that our range is from 1 to n. Then how many questions do we have to ask to find out what our number exactly is? If our range is from 1 to n, how many questions should we ask to find out what our number is? Yeah, okay, we'll talk about that. Exactly, it's going to be log n in base 2. What log says, log exactly says that how many times you have to divide this number by 2 to reach 1. So this way, with log of n questions, you can find out that what this number is. And then even if you had a number and its range was from 1 to it was from 1 to even, for example, 1 billion, up to 10 to the power of 9. How many questions do you need to find out exactly what number is, what that number is? Assume that your number is from 1 to 10 to the 9th. How many questions do you ask approximately? Exactly. With 30 questions, you can find out what that number is exactly. And this is the magic of binary search. So it is called binary because it's like each time we are dividing things by 2. It's like we are doing things, we are doing everything in base 2 this way. That's why it's called binary. So it's like each time we have 2 choices, either we go to left or to go to right. So it's gonna be log of n at the end, and it is called a binary search. If we were splitting into 3 parts, like ternary search, it was called ternary search. So ternary search is not very different. It's another approach that is used in some other problems. Don't think about that for now. It's not important for now. In a future topic stream, we can discuss that as well. But for now, just consider that, I mean, if we would split it into 3 parts, it would be called ternary search. Do you want the link of the CF group? If that is what you want or not. Plus, your question is how many comparisons we need to, yes. I'm saying that how many comparisons we need to find the element in the worst case. So can I always use binary search instead of linear search, or is there certain cases where linear search would be better? Yes, binary search is going to be better for you compared to linear search, going one by one and asking them. I mean, if you're sure that your answer is very small, good thing about linear search is that it is so easy to implement. You have just a for and ask everything. If you can do that, if you can also do a linear search and it's only a limited number of elements, that's your answer is there. You can just do linear search because it's easy to implement. But if it is, I mean, there are your options are a lot. You have to use binary search to achieve, I mean, to make your range smaller and smaller in a fast way. So you have to make it small very fast. So that's why binary search would be better. Hey, Nesh. Nice, Jafar. Yeah. Can you explain more about log? Yeah. Log basically is saying that log of n means that what is the number that 2 should be raised to the power of it to reach n. In other words, n is going to be equal to 2 to the power of log of n. This is log in base 2. When we write LG stands for log in base 2. You can also write it this way, log in base 2 of n. But LG in general stands for log in base 2. So log of n is that to what number? And we should raise 2 to the power of what number to get n. For example, if your n is 8, log of n is going to be 3. Okay. And if n is 9, log of n is going to be 3 point something. Okay. It's going to be a bit more than 3. So this is what log is. Okay. So no, I haven't seen this. Thank you, Adarsh. Okay, so this is basically what binary search is, and a lot of problems in competitive programs, a lot of algorithms use this idea of binary search. This is very useful in solving so many algorithmic problems. Let me fix it a little bit. And we will see today that's how we can use it to solve problems on Codeforces. So many problems. If you participate in, I mean, you solve problems in LeetCode, if you solve problems in Codeforces or any other judge or in coding interviews, you have to come up with algorithms. Binary search is going to be very useful in general. And this is something that everyone should be aware of. And even if you play in a TV show game, also it seems like you have to know it, and you can play a lot better that way. Yeah, we are gonna solve all of the problems that were in the contest today. Let me bring the contest again. So we have 6 problems to discuss today about binary search. I'm gonna discuss them one by one. We're gonna solve them, and we will see that how binary search is gonna be useful to solve the problem, solve coding problems. So let's talk about the first problem first. Interesting drink. So this is the problem. Let me also send you the link of its ID in Codeforces. Yeah, all of these problems have a solution with binary search. Some of them also have solution with some of them, especially the easier ones, also have a solution without binary search, but all of them have solution with their main solution is with binary search. So let's consider this first problem and see what it's saying. Problem 706b, interesting drink. It says that Wassily likes to rest after hard work, so you may often meet him in a sandbar nearby. You know, I mean, to cut the story short, it's saying that we have several bottles in a store. The price of bottle number I is xi. And Wassily plans to buy his favorite drink for q consecutive days. And each day he knows that he's able to spend m sub I coins. So each day he's able to spend some number of coins. And for each day you have to say that how many different shops he can buy a bottle of, or how many different bottles he's able to buy. So in other words, it's like each day he has some amount of money, and you have to say that with this amount of money, how many of these he can buy. So for example, if he has 10, his money is 10, he can either buy this 10 or this 8 or this 6 or this 3, but he cannot buy this 11. So the answer is gonna be 4. If he has only 1, he cannot buy anything. If he has 3, he can only buy these 3. So the answer is 1. And if he has 11, he can buy any of this. So the point is that you have to, in other words, you have to find out how many of these numbers are less than or equal to the number that you have in here. Okay, when we want to solve such a problem, this is a problem that you can just see that how binary search can be used in its easiest form, in its most basic form. So the point is that in here, you're gonna have a list of numbers, which is these xi's. You have these xi's. And each time you get some mi, and you have to find out that how many of these xi's are greater than, are less than or equal to that. So basically, you can first sort this list. Let's consider these numbers x1, x2 to xn. Let's sort them in increasing order. And by sorting, that we have them in increasing order. We're gonna have them in increasing order, arrange them in increasing order. And then, whenever we want to find out for each number, for example, let's say that we have some number y. And we want to find out that how many numbers are less than or equal to y. What we can do is to each time, it's like we want to find the index of the last number. It's like we want to find the last xi that is less than or equal to y. If we find such last xi that is less than or equal to y, with this definition, xi plus 1 must be either out of the array, if I is ni plus 1 is out of the array, or if it is not, it should be greater than 1. So it's like if we find the last element that is less than or equal to y, the answer is going to be the index of that one. So the question is that how we can find that one. Well, what we can do is this. We can just run a binary search. Each time, initially our answer is this in this range. It's from 0 to n. The last index. Initially our answer is 0 because we don't know anything that is less than or equal to y. And we know that the answer can be at most n. The number of the ones that we can buy is at most n. And the point is that each time we can see the middle one, ask the middle one, and see that if that one is less than or equal to y. If that one is less than or equal to y, the next time we can search in this range. We know that our answer is going to be in this range. If it is not, the next time our answer is going to be in this range. So it's like, again, we are splitting it into two parts, and whatever that happens next time, the range that we are searching for an answer in is going to be divided by 2. So this way we can find out that what is the last index that is less than or equal to y, and we can output its index. And how to implement that? How can we implement this? In order to implement binary search, what we can do is, for example, this. Let's implement what we have in here. We can just have some int of L that is initially 0 and some R that initially I consider R as n plus 1. So what I do is that I don't want to touch any number from 1 to n. Basically, what I do in binary search, this is the best practice to implement binary search. So all of you should listen to it, even if you are familiar with binary search. This is the best way to implement binary search. Try to always implement it like this. I see that many people implement it in other ways, but it's the best to implement it like this. Always define your L and R in a way that L says something, R says something else. What do I mean? I mean that, like, assume that, for example, in this case, L is something that can be your answer, or L has this condition that your answer is definitely greater than or equal to L. L has this condition that your answer is definitely greater than or equal to L. We know that our answer is at least 0. So initially what we set for L is okay. Or in other words, it's something that you know that you have this answer. L is something that is definitely fine. So L is something that is definitely fine. Or in other words, we can buy L drinks. On the other hand, we define R in a way that our answer is less than L, or in other words, it is not fine, and it means that we cannot by answer is less than R. We cannot buy R drinks. We cannot, I forgot to write buy. We cannot buy R drinks. So you can see that with this definition, it makes sense that at the beginning we set L as 0, R as n plus 1. This is the best way. This is what I mean, that we define L as something, R as the opposite of it. This should say two different things. This way, whenever you check the middle elements, the mid is you can either move L there or you can move R there, because it has one of these two cases. Either we can do that or we cannot do that. So we can either move L there or we can move R there. This is the best practice to implement binary search, and you don't need those additional plus ones, minus ones inside your while anymore. And we should have a while. How long this while should be continued? How long we should continue this while? I want to continue as long as I'm not sure that's what my answer is. So what should be the condition inside my while? What is the condition that I should have inside my while? I know that L is something that we are sure that it is fine, and R is something that we are sure that we cannot buy. I mean, L is something that we are sure that we can buy L drinks, and R is something that we cannot buy R drinks. We should keep it such that L is in false and R is in true always, or vice versa. Exactly. That's completely okay. That's completely correct. We should definitely set L and R in a way that one of them is false, the other one is true. Exactly. And the conditions is what Pratham is saying. We should continue as long as L plus 1 is less than R. Why is not L less than R? With this definition, is not L less than R. Because L and R will never get equal to each other. We will continue as long as, or in other words, let's say that R minus L is greater than 1. Either we can say R minus L is greater than 1, or, I mean, all of them are the same thing, or L plus 1 is less than R. Why? Because we know that L and R say two different things, so definitely they are never going to be equal. And the point is that when they become adjacent to each other, where L is here and R is exactly next to it, it's like we have the answer now. Because R is something that does not work and L is something that does work. And when they are next to each other, it means that we have the answer. The answer is L. So the point is that once they are next to each other, we know the answer. I mean, so we should continue as long as they are not next to each other, as long as L plus 1 is not R. As long as it happened, we will check mid. We will check int of mid, which is defined as L plus R divided by 2. This is the middle element in this range. And then we should say that if A sub mid or A sub mid minus 1, if you write in 0-based indexing. But for now, let's assume that I'm using, for example, 1-based indexing. If A sub mid was less than or equal to the value that I had, let's assume that it was, for example, y. If it was less than or equal to y, what should I do? If A sub mid was less than or equal to y. Why L cannot be equal to R? Because L and R have different definitions. L is something that we can buy L drinks. R is something that we cannot buy R drinks. And initially, my definitions are in a way that we ensure that we can always buy 0 drinks and we can never buy n plus 1 drinks. So we set L as 0 and R as n plus 1 at the beginning, because this is in a way that we are sure that we can buy L drinks, we cannot buy R drinks. And they cannot, I mean, based on this definition, they cannot be the same, because L is something, R is the opposite of it. So L and R will never be equal. But once they are next to each other, L is going to be the last thing that works, R is going to be the first thing that does not work. And thus, their we can say that L is going to be our answer, our final answer. Exactly. When this happened, we should set L as mid. Exactly. We will update as L mid. And the point is that we don't need mid plus 1. I mean, these plus 1s do not exist anymore in this solution. Why? Because I know that now I found out that I can buy mid drinks. So based on my definition, L is something that we can buy those many drinks. So based on my definition, I can say that L is equal to mid. And then I say that else R is equal to mid because I cannot buy. So this means that I can. So when I can, I should move L there because L is the one that we are sure that we can. And if we cannot, we can move R there because we cannot in that case. Okay, so we will continue as long as L plus 1 is less than R, and at the end L and R are going to be next to each other. You can see that each time R minus L will be divided by 2. And we will continue as long as R minus L is greater than 1. We will keep dividing it by 2. And at the end we can say that L is our answer. We can, for example, see out L. So this is how we can do binaries, and we write an endl at the end as well so that we go to the next line. So this is how we can implement binary search in the best way. This is very important. Make sure that, I mean, if you do it like this, your code would be a lot cleaner. So make sure that you have understood this, and if you can, try to implement binary search like this from now on. And do not use those plus 1, minus 1s, etc. It's always the best if you always assume that L is something, R is the opposite of that. This is the best practice. This is the best way to implement binary search. Yeah, I mean, usually many people write plus 1, minus 1, etc. But the point is that it's better if we implement it like this. Yes, and in this explanation I use 1-based indexing. But if you use 0-based indexing, you have to consider A sub mid minus 1. Yeah, I will talk about that as well next. But first I wanted to say this. Well, that is not known as the general implementation. I mean, the best implementation is this because it's way cleaner and it's way easier to understand, and you don't get confused as well that when you should put plus 1, when you should not put minus 1. And for example, you do not need some additional variable like ans that if it was possible you update ans, etc. So the point is that when you do like this, it's very obvious. I mean, L is something that it works, R is something that does not work. If mid works, you have to move L there. If mid does not work, you have to move R there. Because mid is gonna satisfy the condition of exactly one of these two. So you have to move exactly one of these two here. So this is we can say this is the correct way of implementing binary search, and this is the cleanest way. Why R is n plus 1 here? Well, the point is that with this definition, R is something that I'm sure that I cannot buy R drinks. So I initially set R as n plus 1. I should not set R as n because maybe I can buy n drinks. I have to test n in future. So I set R as something that I'm sure that I cannot buy those many drinks. So I set it as n plus 1. Maybe in future my mid at some point becomes n, and I will check if I can make n or not. I will compare a of n with y. But initially I set R as n plus 1 because I want R to be something that I'm sure that I cannot make it. And see, this is the way that, I mean, when you define it like this, defining L and R at the beginning will be so easy as well. I mean, L should just be something that you're sure that it works. I mean, the greatest number that you're sure it works. R is the least number that you're sure that it doesn't work, so it's like you have a range now. And then each time you consider the mid, and you can move one of them to that mid. Is it clear? Yeah, it would be good if you share some template as well if you have a template. If we select R as n, we would still be able to reach n. So what's the point of n plus 1? Well, no. If we choose R as n, we will never check. Our mid will never be n. You can see that if you set R as n, our L can never reach N. We know that at the end L is our answer, right? L is our answer at the end. L is the greatest thing that we can do, that we can make. If we set R as N, as I said, L and R will never be equal. We will continue as long as R is greater than L plus 1. Because L and R have different definitions, they can never be equal. So if you set R as N, L can never get to N. I mean, it's like you're blocking it. So you have to set it as N plus 1. So make sure that you are doing things, I mean, you are defining the values based on the definitions that you have. Make sure that you are defining the values based on the definition that you have. So R should be something that does not work. So R should be N plus 1. L is something that should work, so L should be 0. Why R is not N? Because we are not yet sure that N does not work. Is it clear? Okay. I just wanted to focus on this because this part was not about the first problem. This was more about the implementation of binary search, which is so important. Yeah, we can also discuss that as well. Yeah. As I said, we have to start from basics for now, but we can discuss, in floating numbers in future, definitely we will discuss that as well. Anyone want to answer my doubt? I would doubt that if... I have used 1-based indexing in here, but if you wanted to use 0-based indexing, the only change that you had to make was to change this mid to mid minus 1. Because then, if you want to buy mid drinks, the last drink that you buy is gonna be drink number mid minus 1. Okay, or x of mid minus 1. So the only change that you had to make if you were using 0-based indexing, I mean your indices were from A0 to AN minus 1, you had to just consider A sub mid minus 1 instead of A sub. Yeah, exactly. If R is equal to N, we will miss exactly one element. Or make L equal to minus 1. We do not need to make L as minus 1 because we are sure that we can buy 0 drinks. So if we are not sure about that and we wanted to test that as well, if we wanted to test 0 as well, we could define it as minus 1. But the point is that our test works for the numbers from 1 to n. I mean, our test is on the indices of the array. So it's from index from 1 to n. And about the element before this range, 0, we are sure that it works. And about the numbers after this range, n plus 1, we are sure that it does not work. And our test, I mean, inside the var test, everything in this range, because it works with a of that index. So this way this way everything will be solved. This number does work, this number does not work, and everything in the middle can be checked in our binary search, in our while. Is it clear? Thanks a lot, Jafar. I'm so happy if it's like that and you can understand it well. So, yeah, and that's not really the normal method as well. I mean, if you look at the way that most top competitive programmers do binary search, for example, you watch codes of tourists or people at that level, they implement, if they have to implement binary search, they implement it like this. Yeah. Sure, Aura. Sure. Okay, nice. So this is how we can implement binary search. Now that we have talked about this implementation, I want to give you probably bad news. We could just avoid all of these things and we could use C++ as a function that can just calculate this for you. I mean, for this simple version of binary search. We cannot always use this, but in this simple version, that in an array, we want to find the last element less than or equal to something. Well, C++, we have to get familiar with these functions of C++ as well. I know that many of you are already familiar. We have two functions. One of them is lower bound, and one of them is upper bound. So we have lower bound and upper bound. So upper bound gives you the first index that is greater than some number in your array. Lower bound gives you the first number that is greater or equal to some number in your array. So basically, when we want to find the latest element that is less than or equal to our y, it means that its next number is the first number that is greater than y. So it's basically upper bound. So what we can do, we can use this upper bound function. Upper bound function works like this: you give the array to it, you give the pointers to the beginning and the end of array. Assume that the name of your array is A. You give the beginning of your array is A itself, the end of your array. If the size of your array is n, for example, like in this problem, the end of it is going to be A plus n, and you give your number y as well. This will return a pointer to you that points to the first place that is greater than y. That it points to the first place that is greater than y. It does binary search itself. It is a function by C++ that does exactly this binary search and finds the first element that is greater than y using binary search. So it works in O of log n. The order of it is going to be log n. It returns the pointer to the first element that is greater than y. And if you subtract A from it, A is the name of array. Do not forget that. A is the name of array. When you subtract A from it, it's like you are subtracting the pointer to the beginning of the array. So it's like you're finding the distance from there to the beginning of your array. This way, it gives you that index, the first index that is greater than y. So if you define it as I is going to be the first index in your array that is going to be greater than y. So basically what you are doing in here is that you do an upper bound, you give the beginning of your array. You can just give A. This points to the beginning of the array. The end of your array is A plus n. So starting from that pointer, you have to go forward by n because the size is n. So this is the end of your array. And y is your number. And then when you got your answer, you will subtract A from it. A was the pointer to the beginning. So it's like you find this distance. And this distance is going to be exactly the index of this element. And we are assuming that we're using zero-based indexing in here. So for example, our array is A0 to AN minus 1. A is like pointing to A0. A plus n is the first element that is outside of your array. I mean, it's like the end of your array because this range is inclusive, exclusive. And then when you get when you get the pointer to the first element that is greater than y, if you subtract it from the beginning of the array, you will find this distance. And when you find this distance, that is going to be exactly the index of this element. So you're going to be sure that AI is the first element that is greater than y. So you know that all the elements from A0 to A of I minus 1 are going to be less than or equal to y. Because AI is the first element that is greater than y. And do not forget that we have sorted the array from the beginning. At the beginning, we said that we sort the array. So now we can say that our answer is going to be I. Because everything from 0 to I minus 1 works. Let me also show you implementation on this one. Let me also show you the implementation. If you look at my code, all I do is this. First, I get all the numbers, and then I sort them. And then for each query, I see in Q, while Q minus minus, for each query, I see in Y, and then I just see out upper bound of X, the beginning of the array, X plus N. The first element that is not in your array. When you add n to the beginning of the pointer, you go n forward by n, and this is the first element that is not in your array, and y, and you subtract x from it, because it's going to give you the distance to the beginning of the array. So you're going to have the size, you're going to have the number of elements that are less than or equal to y, this way. So this way you're going to have your answer at the end. If you wanted to find the first element that was greater than or equal to y, instead of upper bound, you would use lower bound. I mean, in here, we want to find the first element that is greater than, strictly greater than y, because the first element that we cannot buy, the first drink that we cannot buy, its price must be strictly greater than y. If its price had to be, instead of strictly greater than y, it had to be greater than or equal to y, so that we couldn't buy it. We could say lower bounds, x plus n y. So that's the difference between lower bound and upper bound. Is it completely clear? Are you guys okay with it? We have spent a lot of time because I wanted to emphasize on the implementation and what lower bound and upper bound is, and then on the next problems we have to go over them faster. We have around 70 minutes left from this live stream, so we have to go a bit faster. Now, if it is completely clear for you, you can use this emoji or put a plus in the chat. And also, guys, if you want to support my work, I would really appreciate it, and it would be super helpful if you like the video, and if you really like it. If you don't, that's okay. You can even dislike it if you don't like it. You can be honest. But if you like it, I would really appreciate it if you like the video and share it with others as well. That would be super helpful. Okay. What if there is no element greater than the number? Well, the point is that if there is no element greater than the number, it returns n to you. I mean, are the indices are from A0? That was a very good question. Let me also say that. You know that the elements, the indices of the elements are from A0 to A sub n minus 1. As I said, it returns the index of the first element greater than y. If none of them were greater than y, it will return n to you. So the first element outside of the array. If none of them were greater than y, it will return n. Okay. So this is how we lower bound and upper bound work. Okay, are you going to cover search on arbitrary predicate today? I'm gonna talk about. I want to talk about all the problems today that we had in the contest today. But now we have to go a bit faster on the problems. Okay, so now let's talk about the second problem. The second problem in the contest was this perfect team problem. I will send you the link of this problem in Codeforces as well, 1221C. And this problem is saying that assume that you are trying to make an ICPC team. You are trying to make several ICPC teams. You know that you have n people. I mean, you have n people. Each of these people, you have n students. Each of these students can be either a coder or a mathematician or none. I mean, so you have n students. Some of them are coders, some of them are mathematicians, some of them are none. Not coders, not mathematicians. They are not good in any of these two. So people are only of these three types. You want to create as many teams as possible. Each team should consist of 3 members. So you have to construct. You have to construct the maximum number of teams such that each team contains 3 members exactly, and it has at least 1 coder and at least 1 mathematician. So each team needs to have, a team is considered perfect if it includes at least 1 coder, at least 1 mathematician, and it consists of exactly 3 members. In this case, we say that this team is perfect. So now, considering this, you have to say that you are given the number of coders, you are given the number of mathematicians, and you are given the you are given the number of mathematicians and the number of people that are not good in any of these two. They are not coders and mathematicians, and you have to say that what is the maximum number of teams that you can make. Well, again, on this problem, what is the, we know that, let's assume that n is equal to c plus m plus x. N is the total number of students. So first I define n as c plus m plus x. Well, I know that I again define my L and R in binary search. L as 0, R as, what is the maximum number of teams I can make is n third, right? The maximum number of teams that I can make is n third. So what should I set as my R? Based on the implementation that I told you about, based on the implementation of binary search that I told you about. Contest link, let me send you the link to the group, to the Codeforces group. You can find the contest in here. Exactly, it should be n third plus 1, awesome. So you're learning it, that's great. Great. So n third is gonna be the maximum that you can make. So you can set R as n third plus 1. You could also, to be honest, you could also put n plus 1 as well, because it's okay. I mean, the range would be tripled, it would be multiplied by 3, but that would still work. I mean, we could still find the answer. But anyway, so our R will be n thirds plus 1. So now, again, we have to say that while R minus L was greater than 1, or while L plus 1 is less than R, I want to see if I can make mid-terms or I cannot make mid-terms. How do I check that? Well, definitely, if I have mid-terms, I have to have at least that many coders, and I have to have at least that many mathematicians. And our total number of people, n, should be at least 3 times mid as well. The third case is okay for sure. I mean, because our R is n third plus 1, we are sure that the third case is okay. But I can write that as well, so that I write all the conditions. So there are 3 conditions. Mid must be greater than or equal to C. Mid must be greater than or equal to C. And also, mid must be greater than or equal to M. And also, 3 times mid must be less than or equal to n. We should have enough people to make these many things. So we will just check that if all the conditions are satisfied, this would satisfy. This is okay, this is possible, otherwise it is not possible. So we just check that if mid was greater than or equal to C, and mid was greater than or equal to M, and 3 times mid was less than or equal to n. I mean, in C++ you should write it like this, but I hope that you understand what I'm writing. And also about this greater than or equals. In this case, you are able to make these many terms. So what should I say? I'm saying that, you know, the total number of people in these, I want to see if I can construct mid-terms or not. I want to see if I can make mid-terms or not. The point is that I can make mid-terms if and only if 3 times mid must be less than or equal to n. That's definitely one condition, which it always satisfies here, because we set R as n third plus 1, but I write it here as well because it's one of my conditions. I write it. It always satisfies in this case that I set R as n third plus 1, because we only are searching the range from 1 to n third. But anyway, our 3 times mid should be less than or equal to n, and mid must be greater than or equal to C, and must be greater than or equal to M. These are the conditions that we have. We should have enough, mid should be, less than or equal to C and M. We should have enough coders and mathematicians. Less than or equal, We should have enough coders. We should have enough mathematicians. The direction is wrong. We should have enough coders. We should have enough mathematicians. And we should have enough people to make these things. So if all these conditions happen, what should we do? We should set exactly left or L as mid. We do not need this plus 1 anymore, because L is something that we're sure that it works, right? Yeah. So you will always pick both sides, so each try will have at least a common subset consisting of 1. Yeah, exactly. I will make sure that each of the subs, I'm making sure that each of these teams can have one of them. So we have at least mid coders. We need at least m mathematicians, and we need at least 3 times mid people in general. So we can say that in this case, L is gonna be, we change L to mid. Otherwise, it means that it is not possible. So we change R to mid. And at the end, L is gonna be our answer. So anyway, the solution to this one was a simple binary search. We could just each time check mid, and if it was okay, we set L to mid. If it was not okay, we set R to it. And this is how it works. Okay, so quickly we should go to the next problem now. If it is okay, just put a plus or use the 100 emoji. And then we're gonna discuss the next problem as well, cellular network. Yes, exactly. We need to make L and R in opposite realm. Yes. No. Initially, we do not need to find exact values. We should set something that we're sure that works and something that we are sure that it does not work. The point is that at the end we find the exact value. Is it clear? Not always. I mean, for example, you should make sure that if you set higher bound as 10 to the power of 18, you have to make sure that you will not go out of bounds in your array. So if you're calling A of meat, for example, inside your code, you need to make sure that you will not go out of bounds. Okay. There is also an O of 1 solution that you can think about, but because right now we're discussing binary search, I'm not gonna cover that for now. I mean that is not in our interest right now in this session. So anyway, now I will move on to the next one. If you have more time, I would say that, but I think for now it's better to prioritize talking about binary search. If you want, you can see the tutorial and you can also see a solution of O of 1. There exists also a solution without binary search. Anyway, so now let's move on to the third problem, cellular network. This is this problem 702C. Thank you, Adarsh. It will work if L. No. We should set L as mid in this problem. I mean, as I said, in our definition, not L should set as mid. Okay, so let's talk about this next problem, cellular network. Guys, I'm sorry, I try to answer your questions at the end. Sorry that I'm moving to the next problem quickly. I'm trying to manage the time as well. So if you have questions, you can still ask it. And as I said, like in all the streams, you can join our Telegram channel as well and ask further questions there too. So let me send you the link of the Telegram channel as well. You can talk about them in the discussion of Telegram channel as well if you want. So the third problem, 702C cellular network, it is saying that you are given endpoints on the straight line, the positions, x coordinates of the cities and endpoints on the same line. So it means it's saying that we have n cities on the straight line, and you have these n cities. Everything is on a single line. You have n cities and you have m cellular towers. So you have n cities and you have m cellular towers. And all of the towers work in the same way, and they provide cellular network for all cities which are located at the distance which is no more than r from this tower. So each of these cellular towers can provide access. I mean, they can provide cellular network for all the cities within the distance of at most r. So your task is to find minimal r that each city has been provided by cellular network. So a cellular network for each city that there is at least one cellular tower at the distance which is no more than r. So you want to find the minimum r such that you can provide access to all the cities. So let me explain it in here as well. So it's like you have this straight line and you have some cities. Let's show cities with red color. These are your cities. And you also have some cellular towers. They are like this, for instance. You want to choose the smallest possible r such that if each cellular tower can can give access to cellular network to all the cities within the distance of r. So each of them have the coverage of with length r you want to make sure that all the cities are gonna have the access to cellular network. You have to say that what is the minimum R that you can achieve your goal with. What is the minimum R? So how can you find that out? How can you find out the minimum R such that you can provide access to cellular network to all of the cities? Well, the point is that we should again start from the smallest one. Let's use the low and high this time instead of L and R, because R is this value, and I usually also use low and high as well when I want to implement binary search. I always use low and high because L and R are sometimes used variables in other places, but low and high I always use them for binary search. So let's see that what our low should be and what our high should be. What is low? What is something that we are sure that it does not work this time? What is the value that we are sure that this time, if R is more, it's going to be better for us? So this time we should have low as something that we're sure it does not work, and high as something that we're sure that it works. So one suggestion is 0, but 0 might work. I mean, it's possible that 0 works. Maybe if in each city there's also a cellular tower, you can set R as 0 and they would give access to the same point that they are at. So that's why all the cities will have access to cellular network. Exactly. We can set it as -1. -1 is something, I mean, this is not hard to, I mean, maybe it's like you get confused that why we are using -1, but it's so simple. -1 is something that you're sure that it is not the answer. So you want 0 to be checked too. Because you want 0 to be checked too, you set this value 1 less than that. You set it as -1. Okay. So the point is that we can just set our low as -1, and what our high can be. What can be the value of our high? And guys, it's really good that so far tablet has not got disconnected. That's a very good news. I hope that it will continue like this. What our high can be? Exactly, yes. Our high can be like 2 times 10 to the power of 9. High can be like 2 in 9. Yeah, something that is very big and we're sure that it works. N might not work. I mean, because N, we are talking about the distance, and the distance can be up to 2 times 10 to the power of 9. Because the points are from -10 to the power of 9 to 10 to the power of 9 itself. So 2 to the power of 9 is something that we are sure that it works. So don't say otherwise we'll hang again. I said otherwise a lot. I didn't understand that. I didn't notice that. Am I saying otherwise a lot? Anyway, while you're answering, I will continue. So anyway, low must be -1 initially. High must be 2 times 10 to the power of 9, 10 to the 9th. And again, like always, we have to do a while. We say that while low +1 is less than high, while low +1 is less than high, we will continue this. Or while high minus low is greater than 1. I usually write while high minus low is greater than 1. But there's no difference. And then I say that inside, I will see that what is mid. Mid is low plus high divided by 2. And we want to see that if it works or not. How can we find out if it works or not? So now the question is that for some mid, we want to find out if mid works or does not work. How can we find that out? Do you have any suggestions? Let me also bring my code as well. So this is one way that we can see if the answer works or not. I mean, if it is possible to do it or not. City plus mid should encounter a target on either side. Yes, if from each city we go by mid to the left side or to the right side, we should see at least one index, one of the cellular towers. So for each city within this range, there must be at least one cellular tower. So one thing that you can do is to use in here, one thing that you can do is to use like 2 pointers. So assume that we have all cities in sorted order and all the towers in sorted order as well. So we check cities one by one. These are our cities. Whenever we are on a city, when we solve this city and find out, we figured out if there exists a tower or not, we also have a pointer on this one. It's like we know that which tower worked for this one. When we go to the next tower, when we go to the next city, the point is that the tower that gives this answer to this city, is not going to be to the left of the one that gave answer to the previous city. So if you consider all the cities in ascending order of their coordinates and all the towers in the ascending order of their coordinates, the point is that if you see the previous one, the previous city, and see that which tower worked for the previous city, now when you come to this new city, the point is that the tower cannot be to the left of the previous one. The tower should also go forward or stay at the same place. So you can say that while this tower did not work, you will increase this tower. It's like you have a 2 pointer. 1 pointer on the cities, 1 pointer on the towers. When you move the city forward, you will, as long as this tower does not work, you will move that tower forward as well. And if you reach till the end for some city and you have not found anything, then it's not possible. But if for each city you found something, it is possible and we can make it. So basically we are using 2 pointer. So it's like, we just have some int of p1, pointer 1 that starts from 0, p2 that starts from 0. And it's like you have a 4. This instead of this p1 you can have this, you could have this I variable in 4 as well. It's not very different. You need to find the answer for each p1 from 0 to n, and you can say that while p2 was not working, while p2 was less than m, and it was not working, and the distance between these two was greater than mid, you just say p2 plus plus, and you can say that if p2 was m afterwards, it's like we are at m and nothing has worked so far. You can check it here or after this. If this was m, you can say that answer is no. You can have a flag at the beginning and set that flag to true here, that it does not work. And this way at the end, if the flag was true, it means that it does not work. You have to move L there, low there, otherwise you have to move high there. So this is one way that you can implement it, using 2 pointer. Is it clear? I'm not sure I have a code for 2 pointers. There's another solution that my code is in that other solution. I will show that to you. And thanks, crazy memes. Shaman look like Samai right? I think I've got that before. Let me see if it's the same person that I checked before. Yeah, it is. A lot of people say that I look like him. Do I really? How many of you think that I look like him? He's a comedian, right? Comedian somewhere, right? Okay, why can't pointers go back? Well, yeah, I googled him. I do look like him. Okay. Okay. So yeah. So the point is that why you will never go left. The reason is that when you want to, for example, assume that for the previous city this tower worked. When we are going right for the cities, we are going right, definitely for the tower we do not go left, because this city is to the right of the previous city. So if this tower worked for this one, definitely when we go to the right for the city. For the tower, we do not go to the left to find the closest one. If this one was working for this one and the previous one was not working for this, then the previous one does not work for this one as well, because this one is even more to the right. So definitely when we move forward on the cities, the closest towers, the towers that they are at within a distance of mid, they will go only forward as well. They will never go leftward. They will never go backward. So you can have 2 pointers each time. You can move this one forward, and as long as you haven't find something on the other side, you can move that one forward as well. Okay. So some people say that I do look like him. It's semi-right now, right? Some people say that I look like him. Some people say I do not look like him. I look like Jake Gyllenhaal? I don't think so. Honestly. I mean, I mean, you know, I would be proud if it was like that, but I don't think so. Do you think that I'm similar to him? I can ask your opinion. Okay, so anyway, this was one solution. Let me also tell you the other solution as well. The other solution is that what we can also do is to solve the problem in another way. We could instead just move on over all the cities, consider all the cities, and for each city, we could instead try to find out what is the closest tower to it. And I mean, this is the idea. I want that for each city, I wanna find out the closest tower. And so each city gives me some distance. The distance from the closest tower to this city is gonna be this much. And then I can just see that what is the maximum of all these values. The maximum of all these values is gonna be my answer this way. So I can just find out for each city what is the distance to the closest tower. Each one of them give me some distance. So I can just find that what is the maximum of all these numbers. This way, I'm sure that all the cities are okay, because they have a tower that within that distance. And how can I find out the closest tower for each city? I know that each city has some coordinates. And I know that all the towers have some coordinate as well. So it's just enough if I find the latest tower with coordinate less than or equal to this city, and the closest tower to this city is either that one or the tower next to that. I mean, to the right of that. So it's like we have two options for the closest tower to each city. It's either the first tower after that city or the first tower before that city. So this way, I'm like finding the first tower before and the first tower after each city. So I will find, for example, if I just find the first one that has the greater than or equal to, I mean its coordinate is greater than or equal to this one, I can easily find that out with the lower bound. With the lower bound, I can find that what is the first tower that its coordinate is greater than or equal to mine. And I can find and I can check that one and the one before that. And one of them gives me the answers. If I want to show you code as well, you can take a look at it. I have all the cities here and all the towers here as well. So now for each of the cities, I have for I from 0 to n-1. For each of the cities, I find the index of the first tower that has some index greater than or equal to this. I mean, its coordinate is greater than or equal to AI. And I first subtract b from it to convert this pointer to an index, and I then subtract one additional, so that this is going to be the last tower before it. I mean, this is going to be the tower before this. If index was greater than or equal to 0, I say that this d is the distance to the closest tower. I first set it as a very large number. If index was greater than or equal to 0, d will be minimized with ai minus b sub ind index. And if index plus 1 was less than m, d will be minimized with b sub ind plus 1 minus a sub I. And r will be maximum of r and d. So the point is that these two this is the first tower before this city, this is the first tower after this city. I see that what is the minimum distance to these two. We know that the closest one to this city is one of these two. And among all these cities, we will calculate the maximum of these distances. At the end, we see out R, and this will give us the final answer. Is it clear? Let's be fast because we have still 3 problems to discuss. So if it is clear, use this emoji or put a plus. My rating is gonna be less than your rating. So what is your rating right now? I mean, it's good if that happens. I really like my students to see their rating gets greater than mine, because now I'm not doing contest anymore, so I'm more as a teacher now. So I would be okay with that. Okay, so are you guys all okay with it? So good. So I mean, if you have any questions, feel free to ask. I mean, if there are any questions that you're not okay, let me know. No, it won't. I mean, it's gonna be okay. Just be confident. That definitely it's possible. I mean, if you participate actively and do training, you can definitely reach there. I'm saying that you can go past my rating. Okay, nice. So let's talk about the next problem. So this is the next problem, travel card, the problem D. I will send you the link in the chat as well. 756B. These people understand it. Okay. So this next problem, travel card 756B is saying that we have a metro system and we have someone who's using this metro, this public transport. And what he can do is, for buying tickets, what he can do is that he can buy a ticket for one trip that costs $20, 20 bytes and rupees. I call it bucks instead. So he can buy a ticket for one trip for $20, or a ticket for 90 minutes with $50, or a ticket for one day, 40 minutes, that costs $120. And you are given the time of the trips that he has, and after getting each of his trips, you have to say that what is the minimum cost that he can pay in total for all his trips so far. Or more accurately, it says that how much the cost increases when you add this trip as well. So first, assume that initially he has only this trip. He can just pay $20 for this only one trip. So his cost will be 20. And then he has another trip at time 20. Well, he has to spend 20 more because he has to buy one more ticket for one other trip. But the third time that he adds another trip, he does not need to add $20. He can, instead of buying trips one by one, buy one ticket for 90 minutes that costs 50. So instead of 40, he can buy 50 here. So he needs to pay 10 more bucks. So after adding each one of these new trips that he has, you have to say that how much his cost will increase. And all these TIs are given in increasing order, in ascending order. So you will never get some time that is less than the last time that you got. So you have to say that what is going to be the cost, well, how much the cost is going to increase after each trip. This is a problem that uses both DP and binary search. How does this work? Let me drink water for a second. Yesterday I figured out that it's good to always have a cup of water on the desk. So anyway, so we say that we can consider some dp of I. That means that what is the maximum, what is the minimum price that we can pay to be able to make the first I trips. So dp of I says that what is the minimum amount to pay if we want to do the first I trips. So how the P of I can be calculated? Well, I say that there are several choices for the last ticket that I've bought. For the last ticket that it's not a black, oh, I see. That was funny actually. No, I assured you that this is water. Yeah. Okay, so the problem statement was not clear. So yes, sure, I will explain it again. So this is saying that you have a public transportation system and you can buy tickets for it. And the point is that you can buy either one trip for 20 bucks, or you can pay for a 90 minutes pass for 50 bucks, or you can buy a ticket for a day pass with 120 bucks. And you want to figure out what is the optimal way to buy tickets if you have some flights. And the point is that I say the point is that a lot. I just figured out. We can say that each time some other trip will be added, some new trip will be added at some time, and you have to say that what is the cost so far. You have to say that how much the cost has been increased if we do optimally. So, for example, when we have this first trip, the best thing that we can do is to buy one trip. So it's gonna cost us 20. The second trip is gonna cost us 20 more bucks, because another 20 bucks, because again we have to buy another trip. But for the third one, we do not need to pay an additional 20 bucks. Instead, we could just pay 50 at the beginning. Our optimal will change. Instead, it was better to pay 50 at the beginning, and instead of 40, we would cost 50 when we add this third trip. So 10 will be added to our answer. So each time we have to say that if we work optimally, how much the cost will increase compared to the case that before we were acting optimally, before adding this last trip. Is the statement clear now? Could you explain the second answer, please? Yes. In the second one, again, we have 13, we have to pay 20 bucks for it. Then we have 45, we have to pay 20 bucks for it. Then we have 46. Again, it's very similar to this case. Again, instead of buying this, we could buy a 90-minute pass. So we have to buy pay 10 more bucks. And then after that, for the 60, we do not need to pay anything. Because for the 60, we already have the pass. If we buy a pass for 90 minutes at time 13, if we buy a 90-minute pass, then it's gonna cover 60 as well. And then we have 103. The point is that the ticket that we buy in here, I again said the point is that this ticket will expire by this time. It will expire 90 minutes after the start. So you cannot use it anymore in here. So you have to pay another 20 bucks. After that, you have 115. And it says that you do not need to pay anything. Why? Because instead you could pay that 20 bucks for the first trip in here and then buy the 90-minute pass in here. It was more optimal. Then it would cover everything till here. And 126 does not need add any cost as well. Then 150 needs another pass. 256 needs another pass. And for 516, you need to add an additional 10 as well. Because, the last one, you have to add an additional 10, because instead of all this, you could just buy a one-day ticket, and it would cost 120. So if you look at it, the sum of this number should be 120. It's 40, 50, 70, 90, 110, and 120. The point is that previously we were paying 110. Now we can cancel all of those and instead buy a one-day pass. So we would get 120. Is it clear now? Is the statement clear now? Yeah, I will show it to you while when I explain the solution. Why I can't see 50 bucks? 50 bucks is the price for 90 minutes. 120 bucks is the price for a day, and 20 bucks is the price for one trip. So anyway, oh my god, we have only 30 minutes left. So what we can say is that, you know, we can look at it. Let me also show it with a visual explanation. Let me show you visually. So what we can say is, when each strip will be added, we either can have, this last strip, consider this last strip. Either we'll have this last strip, we buy it separately. If we buy it separately, how does it work? How does dp of I will be calculated? We had some trips before. If we separately, independently, we buy another ticket for this one, how would the answer be? How would the answer look like? How would the answer look like? Arpit Bala Nigeria accent. It's so off topic, but I'm interested actually. How is it? Is it close to my accent? How do you rate my accent? How does it look like Nigerian accent? Or dp of I is gonna be dp of I minus 1 plus 20, exactly. Thanks by the way. Fine. Iranian. Have you heard Iranian accents before? So yes, so in this case, if dp of I, when we want to see dp of I, the point is that we can consider, again I said the point is that, what's wrong with me? How can I stop saying it? I'm starting to believe that there's something wrong with me, that I'm using this a lot. I don't know if you have seen this before or not. Some people, when they use a phrase a lot, they have a jar and they penalize themselves. They put some money in it each time they say that. Maybe I can use that. Alireza Firuzja, you know Alireza Firuzja? Yeah, he plays chess and it's so good. Okay, so I'm going off topic again. So if you have dp of I, if you want to calculate dp of I, it is possible that you will buy a separate pass for this one. In that case, dp of I will be calculated from dp of I minus 1 plus 20. It means that, okay, solve the previous ones optimally and then buy an additional pass for this. Or we will cover this with a 90-minute pass. How would the answer look like that way? It means that we have to buy a pass, and the best case if we do it as soon as possible. So we do it in a way that it ends here. So it would cover several trips. So how would our cost be that way? How would dp of I be solved that way? We can watch it at the end probably. Can Cheyenne use the N-word? I don't think so. Exactly. If we find the latest index like J, we just need to find out what is the first strip that will not be covered. So we need to find out what is the first strip before it that will not be covered if we buy a 90-minute pass. And let's call it index J. So our dp will be calculated from dp of J plus 50 for this one. And also if we buy a 1-day pass, it's going to be only a longer interval. So we need to find out what is the first index. Let's call it like K. What is the first index like K that this range will not cover, and our dp will be updated from dp of K plus 120. And how can we find them out? How can we find out these indices? By binary search. So let me also show you the code for this one. Let me also show you the code. The point is that, again said the point is, so what we can do in here is that we can have a for and see all the TIs, and then we can find the indices of the first. With the upper one, we can easily find the indices of the first first trips that their time have that much difference. We know that if our latest pass has length 90, the previous trip, the first trip that it will not be covered, is going to be this one. We need to find out the first element that is greater than ti minus 90, and we have to subtract t from it so that to convert the pointer to an actual index. So ID1 is the first one that will not be covered if we buy a 90-minute pass. ID2 is the same thing, just if we buy a one-day pass. It's the first trip, the latest trip that will not be covered if we buy a one-day pass. And then at the end we say that our dp of I will be, it will be dp of I minus 1 plus 20. This is a bit more complicated because I also handled the case where I is 0. I didn't want to call dp of minus 1. So it is either dp of I minus 1 plus 20, or it is dp of ID1 plus 50, or it is dp of ID2 plus 120. And at the end I will just see out dp of I minus dp of I minus 1. It seems like back then I liked this short ifs a lot because I used it a lot. It is 2017, the beginning of 2017. And man, do you believe that 8 years has passed from then? 2017. That's great. It's really helpful. Please drive around the code using example. Well, I would do that, but I have to really do it very fast because I really want to cover all the problems, and I have to leave sharp at 10. It's 9:36 here in the morning. So yeah, I will explain it. I would do that now. So let me show it in this case. So what I do is this. First, for this one, maybe let me zoom in more. Okay, this is the maximum that I can zoom in. So initially for this one, my DP for this one is gonna be 20, because the best thing that I can do is to buy one pass ticket in here. And when I go to the next one, if I buy one pass ticket, it's gonna be 20 plus 20 for the previous one, so my DP will be 40 this way. Or I can buy a 90-minute pass for 50. My cost is gonna be 50 then. Or if I buy a one-day pass, it's gonna be 120. So the best cost that we can have is 40 if I buy another one pass here. And when I come here, I can buy one additional pass. My cost is gonna be 60 there. But I can also buy a 90-minute pass. And then what is gonna be the first trip that is not gonna be covered? No trip. It's gonna be DP of 0. The best way, if I wanted to implement that code that I implemented right now, DP of I would mean that the minimum cost if I have done the first I trips. So DP of 0 is always 0. It means that if I have done the first 0 trips, if I have done nothing. So it will be updated from DP of 0. DP of 3 can be updated from DP of 0 plus 50. Because 0 is the last thing that I will not cover if I buy a 90-minute pass. It means that everything will be covered. So my cost will be 50. And at the end, I will just print the differences between these two. So first I write this 20, and then I write this. First I'm adding 20, so I write 20. And then I'm adding 20, so I write 20. And then I'm adding 10. And then for 60, I see that my cost is going to be again 50, because if I buy a 90-minute pass, it's going to be DP of 0 plus 50. If I buy a one pass, it's going to be DP of 3 plus 1. For this one, I either buy a one pass, this way I get 70, or I buy a 90-minute pass, which is going to be DP of this 13 plus 50. In both of cases, I get 70. In this one, I either buy another pass, which is going to be 90, or my cost is going to be 90, or I'm going to buy a 90-minute pass. In that case, the first trip before that, the latest trip that will not be covered, is going to be this 13. So my cost is going to be 50 plus this 20. So my cost again is going to be 70. And then I have this 126. Again, either I buy a 90-minute pass or I buy another pass, another one-time pass. So if I buy another one-time pass, it's going to be 19. If I got a 90-minute pass, the first one that will not be covered is going to be this 13 again. So again, my cost is going to be 70, and so on. When I get to the last one, I see that in the last time, the DP that I will be updated from is going to be DP of 0 plus 120. That would give me a better answer compared to all the other cases. So the last DP, if I continue like this, the other DPs will calculate as well, and I will get 120. Is it clear now? So yeah, in this problem, I'm using binary search plus DP. Is it clear? Currently, where are you working? Are you asking me? In which topic you are doing PhD? I'm doing PhD in computer science. It's very good to learn from you, knowing with free lectures like this. Thanks a lot, please. Thank you very much. If you want to support my work, as I said, I think you can help me a lot if you are willing to. And I would really appreciate it if you really help me. You can like the videos, subscribe to the channel, and you can also share it, especially share it with others so that others can see the topic streams as well. You can definitely help the channel to grow. Yeah. So, are you from Isfahan? I'm not. I'm from Tehran. So if you want to help, I think each one of you can share this topic stream with 3 people. I think this way exponentially things can grow. If each one of you share with 3 people or so. Yeah. So anyway, if it is okay, now let's move on to the next problem as well. I think we have limited time, and maybe I can show it for a second and see what happens. Maybe as a fun rest
the law.
for you guys.
As per the fucking law. Stop thinking that I am a racist man. A Nigerian lawyer will fight as per the law. He will argue as per the law, as per the procedure set in law.
That was interesting. Thank you for sending it. We can watch it completely next time that we have time. Yeah, but I think that it was a bit... maybe it wasn't... if you want to use polite language here, it wasn't. But honestly, it was funny. So, we can now move on to the next problem. Is it this too easy problem, or we had another problem as well? Okay. You're wasting our time. Crazy man. Yeah, but yeah, it was a good rest though. So the next problem, too many problems. And we really have too many problems. That's really true. So it says that you are preparing for an exam on a schedule in theory. The exam will last for 10 milliseconds and will consist of n problems. You can either solve problem I in exactly 10 milliseconds or ignore it and spend no time. You don't need time to rest after solving a problem either. So suppose at the end, the score that you will get, each problem has some AI assigned to it, and you get a score for solving that problem. Come on, I do not have enough charge. Let me find my charger. So, okay, I got my charger in a really weird way. If I do not mess up with everything, I finally got it. Okay, let me see if everything is fine. Yeah, it is. So, it's saying that you get a score from a problem if and only if you solve at most AI problems overall. So if you solve more than AI problems, each problem has some AI value assigned to it. You solve this problem. If you get a score from this problem, if you solve it, and you solve at most a sub I problems in total. Okay. You have to say that okay, the link to the question is also 930D. The ID is 930D. I sent you the link. And the problem is saying that what is the maximum score that you can get this way? Do not forget that we have to solve all the problems in 10 milliseconds, and Other than that, we get a score from a problem if and only if we solve at most AI problems, A sub I problems. Is it clear? That's what the statement is saying. So each problem, to solve each problem, we can spend we have to spend ti time to solve problem number I, and we only get a score from that problem if and only if we will solve at most AI problems. If we solve more than AI problems, that problem does not give us any score. Can you post a list of topics that needed for CP? Yeah, I think I can do that as well. There are a lot of things that I'm planning to do I haven't done yet. But in Telegram channel, I'm now putting a vote about the things that you want me to do, especially the videos that you want me to make. I should also put another comments there to that what guideline videos you want me to do, because I want to see that in which stage you are and what is most important to. But anyway, is the problem clear so far? So you want to see that what is the maximum score that you can get. For each problem, you're gonna have some score, some AI that if you solve more than AI problems, that problem does not give you a score, and it takes some time. You are given the time that you have and the AIs and TIs, and you have to say that what is the maximum score that you can get at the end. Okay. Yes, exactly. It's another binary search on an answer. How does that work? Well, first of all, what I say is this. First of all, I say that if solving a problem does not give you a score, then do not solve that problem. If it does not give you a score, why solving that? Do not solve it, then you will spend less time, and the total number of problems that you have solved would be less as well, so probably it would be even better for you. I got a WhatsApp call. So anyway, this way, if we do this, both the number of problems that we solve would be less, so probably we will get even more points, and also the time we spend is gonna be less. So what we can do, we can have a binary search on K, which is our answer at the end. Assume that we're gonna solve K problems. Assume that we're gonna solve K problems. Well, the point is that if you solve K problems, you will only use the problems that their AIs are greater than or equal to K. Definitely you're not going to use the ones which AI is less than K, because if you use them, that doesn't give you any score. So why doing that? Why should you do that? So now that we know this, now that we know how this works, when we know what our answer is going to be at the end, we can filter everything that is less than K, and among the ones that are greater than or equal to K, we can sort them by their time, the time that they take, and we can just take the first K1 of them. If the first K1 of them, the sum of them was less than T, the answer is yes. Otherwise, the answer is no. Is it clear? I hope that this quickly we can handle this problem. This way we can solve the last problem as well in the remaining 12 minutes. Hey, I need to learn CP. What will do though? I definitely recommend to you to watch topic streams first. That would be the first step. That is what is designed for you. You can also join the Telegram channel if you want, and if I made some of these things that you are looking for, like these sheets, etc., I can share it with you both on Discord and Telegram. Maybe you could make short streams covering different topics at short time. Probably. Yeah. My age. You know my age. I mean, I said it a lot in these streams. So if the solution of this problem is clear, please use this emoji or put a plus so that I will move on to the next one. If it is not, also let me know. So, yes, I am 25. How old do I look like? If you wanted to guess that's how old I am, how would you guess that? What is this party? emoji. Thank you. I'm glad if it's helping you. 2252 makes sense. I do look 52. Okay, so let's move on to the next problem now. The last problem. We finally got there. Honestly, I didn't think that we can make it. So, the next problem is saying this, random task problem 431D. I think no one have solved it today in the contest. Solve your daily problem using BS. What is daily problem? Let's go daily problem. This problem, random task is saying that one day after a difficult lecture, a diligent student such as saw a graphite desk in the classroom. Well, it says that you need to find the minimum integer n such that among the numbers n plus 1 to 2n, there are exactly m numbers which binary representation contains exactly k digits k digits of 1. So you want to find the smallest number n, you want to find the smallest number n such that among the numbers n plus 1, n plus 2 to 2n, there exists exactly k digits 1. And it is guaranteed that the answer is at most 10 to the power of 18. Is the statement clear? It is a very, very short problem. Life daily problem. I don't know what is life daily problem. Yeah, probably. So, well, the main catch in this problem, the main observation in this problem is that this function, let's call this f of n. F of n is that how many numbers among the numbers from n plus 1 to 2n, how many numbers have exactly how many numbers have exactly k digits 1. So, let's call it f of n. So f of n is that how many numbers from n plus 1 to 2n have exactly how many numbers from n plus 1 to 2n have exactly k digits 1. So I show you that f of n is increasing and it is binary searchable. I mean, a function must be monotone to be binary searchable. I show that it is binary searchable and it is monotone. F of n plus 1 is really greater than or equal to f of n. Why? Because in f of n, you consider numbers n plus 1 to 2n, right? 2n minus 1, 2n. In n plus 1, you consider the numbers from n plus 1 to, let's continue this, 2n plus 1, 2n plus 2, right? These are the numbers you have for n plus 1. But the point is that these numbers are the same. And also, another important thing is that 2n plus 2 and you are removing, it's up to 2n minus 1. I mean, it's from n plus 1 to 2n. So let me change it a little bit. It's from n plus 1 to 2n. So for n, I mean, if you take a look at it, let's call this f of n. It's from n plus 1 to 2n, not from n to 2n. So this one starts from n plus 1, this one starts from n plus 2. Let's write it here. This one starts from n plus 2. So the point is that these ones are the same. And the point is that n plus 1 and 2n plus 2 have the exact number of ones in their binary representation. Because 2n plus 2 is twice of n plus 1, so it's like we're adding an additional 0 at the end of it. The number of ones that they have are the same. So it has everything that one has, only 2n plus 1 is added as well. So the point is that the number of numbers with k digits 1 will be increased when you go from f of n to f of n plus 1. And that is useful because then you can use binary search when you know that it is monotone, it is increasing. You can do binary search on n and each time see that what is f of n. And then by finding that out, if it was less than k, you can search in the numbers greater than that. In this binary search is in the range from 0 to 10 to the power of 18. If it was more than that, you will search in the ones more than that, otherwise you search in the ones less than that. And how do you calculate f of n? As on that now we want to implement a function to calculate f of n. F of n is gonna be like, let's calculate some value g of, as on that this is for some range. This is for the range of n plus 1 to 2n, right? And what is range of n plus 1 to 2n? Range of n plus 1 to 2n. Now I'm talking about how to calculate f of n. We know that if we calculate f of n, we can do a binary search and find out the answer. Now that we have this f of n, now the problem is that how to find out f of n. Range of n plus 1 and 2n is equal to range of 0 to 2n minus range of 0 to n. Right? So it's like prefix sum idea. And then this way it's only enough to solve the range starting from 0 to some x. And how can we solve that? Well, we want to find out all the numbers less than or equal to x such that they have k digits 1 in their binary representation. We can fix that. Where is the first index that they are different from x? In that index, x must be 1, this number must be 0. And then, what we can say is this. We can see that how many 1s we had so far, and the rest of the digits can be anything. It's like, if we had y once so far, in here we need to have k minus y once. So it's just a combination. We should just see that, if there are, L digits left, it's going to be L choose k minus y in here. So this way we can see that how many ways do we have for that, and we can just using first we use binary search and to calculate f of n for each, and we just do this range. We will say that it is going to be equal to range from 0 to 2n minus range from 0 to n, and when we want to calculate some range, we just fix that what is the first bit that is different. That it was 1 in x and it's 0 for you. And then if you just consider that, the rest of the digits you're going to have some limited digits afterwards, and you have to choose some of them to be 1. And because the lengths are up to 18, the order is going to be O of length, so it's going to be 18 as well. It's going to be O of log in base 10, and all the logs are the same when we talk about their complexity, their order. So it's going to be log of 10 to the power of 18, log of the maximum number you can have. Is it clear? 26. What is 26? 26 is the age that I look like, or something else? If the solution was clear, please again put a plus or use this emoji. And good, it's really a good news that we solved this problem. Let me also show the code, since we have a few minutes left. 2 minutes, now 2 minutes only. So our code can be like this. We just do a binary search, and in our binary search, you see in here, this is March of 2017. I was doing binary search in the correct way back then. So I do a binary search, and I see that what is get of 2 times int minus get of. And this get is exactly the function that I was talking about. It just counts that from 0 to that number, how many numbers have these many set bits. And in our get, I just have a 4 on all the bits. I want to find the first bit that is different between this number v that is given to the get and the number that we're going to consider. And then in that one, this dp is combination. This is the value of the combinations. dp of I and j is I choose j. And then I say that when this car says that how many ones I had so far, we can say that whenever I saw a 1, I can put a 0 in my number, and I can say that if car was less than or equal to k, I can just call dp of I and k minus car. And this way my answer can be easily calculated. I hope that it is completely clear for you. Visit Swan Sure. I visited it when I was a kid, but I mean I barely remember it. I visited there when I was a kid, though. Okay, so we are exactly on time. I hope that this stream was helpful for you. I hope that you learned something about it, from it, and you learned something about binary search. And tomorrow we're gonna also have lead code solution discussion. Hope to see you there as well. And we're gonna also continue these topic streams as well. And you can also say in the Telegram channel that's what you want to be discussed next. Thank you very much, guys, for joining today as well. It was nice to see you again. And I hope that you really enjoyed this live stream. So, Khuda Hafiz for now. Bye-bye. Khuda Hafiz means bye-bye in Persian. Bye-bye. You just joined? You can start, I mean the video is recorded. You can watch the video from the beginning. Bye-bye.